In our last class, we started talking about Python and what Python is and how you can use
Yeah,
Python. Yes,
that our last class, I really missed a lot.
yes, because
That
of the
last class,
network.
I attended it in Kogi State.
Okay,
Maybe that would be the last class I will attend outside Lagos. I will be seeing, I'll be hearing your voice. I will not be seeing your screen. I
yeah,
will log out, come in. The network was very terrible.
yes, yeah, I
It was
understand.
not.
Yes, I understand because I know that at the point it went off and it was just me and Mr. Elijah. So it's network. So I hope today will not be like that. But nevertheless, whatever we discussed in the last class, you can catch up on the videos. So with time, so you just need to like watch the video and spend some quality time practicing whatever you saw on the video. Then if you have any
Mm,
challenge, you can let me know.
yes, sir.
All right. Okay. Let's get into today's task. So in our last class, I explained to you that in my own experience, if you really want to be good in programming, you just need to understand three concepts basically. And those three concepts was broken down in the first part of the class where we discussed about the concept of input, process, and output. Once you know how to get an input into the computer program or into a computer and you know how to perform a process, this is where the real logic happen and you know how to what return back an output. So these are the three concepts that you need to focus on. And in our last class, everything we thought about was all about focusing on what on the input, understanding the kind of data. Because when we talk about input, we are talking about data. Understand the kind of data and data types that we have in Python programming language, what you can do with them, how to manipulate them, what are the method each and every one of them can do, which one is mutable, which one is not mutable. You understand? We discuss all of that. What operators can be used on any of the data type. All of that was discussed. So that gives us a starting point. And today we are going to be diving into processes, which is where logic happen. This is where your control, how to control what to do, and how each of these data is meant to work together. So that is what the project is all about. So I'll go into our project folder, still learning Python. So we'll create a new file for this and I'm going to name this. So we start with control flow. Control flow. So I'll just name this control flow.py. Alright. So when we talk about control flow, I think I didn't spell that correctly. So when we are talking about control flow, what do we mean? So let me put a comment here. So control flow. So when we talk about control flow, it simply means the flow of your program. How is the program going to be flow? What are the steps or what are the actions that your program can take? So and this control flow, one you can have what we call a conditional statement. Conditional statements and you can have what we call loop or repetition as it may be. So these are the two control flow that we have. How do you perform a conditional statement and how do you perform loop in Python programming? Let's start by discussing about the conditional statement. So when we talk about conditional statement, what is conditional statement? When we talk about conditional statement, we are talking about statements that when you evaluate them or when you execute them, they get returned true or false. That is what we call conditional statement. This is not only in Python. This concept cuts across every computer field, computer science field. So
Can I come again? You said when you run them, they come with either true or false.
yes, these are the kind of execution. The kind of statement that when you execute them, they return either true or false. So which means they are also a valid line of code. When we say statement, statement means line of code or a complete line of code. You understand? So when you execute this line of code, the only output they give to you are either what, true or false. So those are conditional statements. So when you talk about conditional statements, there's no way you'll not be talking about conditional operators. So mostly conditional operators are used together with what, conditional statements. So these conditional operators, let's quickly uh, name them. So every operators that we discussed in the last class basically are what, are arithmetic operators. So when we talk about conditional operators, we are talking about what, equals to, this equals to in Python, not equals to, greater than, less than. We also have what, greater than or equals to, less than or equals to. You understand? These are the what, conditional operators. So anytime you use this operator in a statement, they will usually return what, either true or false. Example, let's write a command. Imagine I have a variable num1 equals to 8 and I have num2 equals to 9. And for example, if I say print num1 equals to num2, now this is a statement, and you can see that between these two statements we have two variables, which is num1 and num2. This operator or the sign, which is two equal, that is what equals to in Python. The single equal, this one is called the assignment operator. So we use this one to assign a value to a variable, but we use this guy.
Can you enlarge your
All right, is it better?
no, it's still the same thing.
It's not the same thing. I've increased this. Is that
Okay.
all right? So this kind of operator, the double equal is what, equals to in Python. Why the single equal simply means what, assignment operator. So if I execute this code, which I'm going to do from my terminal using my Python command, python dash control flow.py. Now when you execute this, you can see what gets returned. It returns what, false. And false is what kind of data type? Based on our last class, false is what kind of data type in Python? Any idea? Boolean. So that means when we are talking about conditional statements, we are talking about statements that only return Boolean value, because they will only return either true or false. So simply because num1, the value in num1 is not equal to the value in num2, because 8 is not equals to 9, so we're having false. But what happened if I say num1 is 8 and num2 is also 8? If I execute this again, I get a what? I get a true, because truly num1 is equal to what? Num2. So same thing with every other of these operator. So you can use them as well. Not equals to, greater than, less than, greater than or equals to, greater, less than or equals to. All these are conditional operator. So we have so many of them as well. You can check them up online. I think I can also put the and the or. So you can also, but I will not classify this as conditional operator, but let's just include it there. So the and the or. So all right, now let's continue now. So when we talk about conditional statements, aside that you need to understand the operator, you also need to understand what are the the conditional the conditional should I call it syntax? How do you define a conditional uh a conditional statement? Whenever you want to define a conditional statement, usually conditional statement usually have three keywords. They usually have a keyword, if, elif, and else. So a complete conditional statement will usually have these keyword. When we say keyword, it means reserved words, word that has been reserved by Python, and you can never use it, or you should never use it for any other thing except for what it has been defined for. You should never use if to create a variable. Don't use elif for defining a variable, because they are both keyword. So when we are defining conditional statement, it usually starts with what? If, then followed by what? A condition. So try and follow me. It has what? We usually start with an if, then a condition. You already know what a condition is. That means that part of the code or that statement in Python that will evaluate to either true or false, right? So just like, for example, how I defined num1 earlier on to be equals to 8, and my num2 equals to 9. So if I want to define a conditional statement, if I go ahead and say if num1 equals num2, this is a conditional statement. So take note of that. If, then followed by a condition, then after that condition, the condition can be one or more, can have many conditions, the same way that we all know everything in life happen, or any event in life happen based on the what? On the condition. So this happen probably because something like this happen. So sometimes an event can depend on two or more events happening. But right now let's focus on only one condition. So let's assume I have this condition, then after that condition you have to put a semicolon. You have to put a what? A colon rather, a colon. Then you hit enter. So the moment you hit enter, you see that this my cursor didn't start immediately
Yeah.
on this spot, so it's starting somewhere here. So that is because in Python constructs code based on indentation. Because right now what we are trying to tell the program is that if this condition is true, I want to do something. And what do you want to do? Probably I want to print hooray. So if that's what I want to print, so this is a condition, and the condition states that what? If num1 plus num if num1 equals to num2, print hooray. So you can see that this print is under this, is indented under this if statement. That means this line of code will only get executed if and only if this condition is met. Let's execute this code again. If I go to my terminal and execute this again, you can see that nothing gets executed. Nothing gets executed, unlike before when I just put print. Like for example, now let me put print somewhere here. If I say print and I say not under the if block. Now if I execute this code again, now what do you see? The euro doesn't get printed out, but the not under the if block got printed. Why? Because this print statement is not under this conditional statement. So which means that this guy does not depend on any condition, but this guy, which is this print, depend on a condition, which means that whether if the condition is met or not. So that means this part of your code will not get executed if the condition is not met, and this is what we refer to as what? As control flow. Are you getting me? So this is a control. That means that now in our code now, it happens that a code will only run if a condition is met. Is that understood? Now because this is not true, hooray doesn't get executed. Now let's manipulate our code so that this condition can be true. Imagine I have a 8 here, so obviously we know that 8 is equals to 8. That means this condition will be definitely true. So because it is true, our code is going to execute this print within the if statement. Now let's execute this again. Now you can see both the array and the not under the if block got executed. Why? Because here the condition was met, so it executed this. So that is what? That is if statement. You understand? So but it is always good that when you have if statements, you can also have what? The else. So just like earlier on when the condition was not met, instead of it not returning anything, you could basically just include what else, and else does not take any condition. I can just print oops. I just print oops, I'm disappointed, right? So now this time around, if the condition is not met, there's a what? There's a fallback mechanism. It's just like when you are trying to log in into a system, or when you are trying to cash a withdrawal from your POS machine. If you don't have up to that amount, what do you get? You get a what? A transaction decline message. That is because there's a what? There's a fallback mechanism that if this does not happen, let this happen. So if this condition is not met, just tell me that what ops or oops. Like, let me clear my terminal and run this again. Now you can see, because the condition is not met, this part of the block got executed. But what happens if the condition is met? The array get what? Executed. This is a basic conditional what construct. It has
But
if.
what's the difference between the if and else now?
Now there are differences. The if usually will start your conditional statement. That's the first difference. The if is always starting the conditional statement, and the else is always ending a conditional statement. Another difference, the if has a what? A condition. The if is testing a condition. The if is testing if the condition is met, while the else does not has any condition. So that means that when your program has checked all conditions and no conditions has been met, that means none of them is true, that is when the else will get executed.
Okay.
Is that understood? All right. But in a case whereby you have more than one condition that you want to test, imagine I twist my code a little bit. Let's assume I say if num1 equals to 3, and I say hooray, I have a 3, and I still want to check if, what if num1 is equals to 5, or let's say 8. I want to say print hooray. This time around I have a 8. Now you can see I have two conditions, right? Now the first condition is testing if num1 is equals to 3. That means only if and only if num1 is equals to 3, this will be executed. And if num1 is equals to what? 8, this will be what? Executed, right? So this is a what? Multiple condition. But even though this works in Python, it is not good enough, right? Because you see everything I have here are still talking about a single condition. They're like a single construct. I'm still testing a single scenario, right? So instead of you having multiple if, you can basically say what? Elif. And what does elif stands for? Elif stands for what?
Else if.
Else
Else
if.
if.
So you can say it's a statement. If this is equals to this, say this. Else, if this is equals to this, say this. You can have as many as possible elif in your construct, but it is good and advisable, best practice, that you should only have one if, and else can only be one. So if I execute my code now, which part of this print will get executed? Which one?
The elif now.
The elif will get executed. Why? Because num1 is equals to what? 8. So what do we notice about conditional statement? One thing that you need to understand about conditional statement is that, one, it works from the top to the bottom. So that means the condition is being tested from the top, and once the condition has been met, every part of your code is neglected. That means if the condition, for example, if num1 is equal to 3 here, Let's say number one is equals to 3. The moment he execute this guy, he neglects all the part of this conditional statement. He doesn't even bother to go ahead and look for them anymore. What do I mean by that? Imagine I said number 1 is equals to 3 here, and number 1 too is also equals to 3. Which one do you think it should be executed? Because based on what we've explained now, we say anywhere the
Okay.
condition is true, we get
True.
executed. So which
Yes.
of this part of the print will get executed?
Both will get executed.
Both will get
But
executed.
yes,
Why?
yes, because number one is three, and
And here too number
in
1 is
both
3.
cases it's also three. Yes.
Alright, let's try
Oh
that.
wait. Okay.
Alright, so if we try that, what do you see? We have
Yeah.
Uri, I have a 3, but it didn't print what? Uri, I have a 8. It didn't. That's why,
Okay.
because the condition has been what? Has been met. So once the condition has been met, it didn't bother checking for every any other part of the any other part of the of the condition. Is that understood? So note that about a conditional statement. So now two things that you need to take from here. Conditional statements works together with what? Conditional operator. There's no way you want to define a conditional statement that you are not going to use a conditional operator, because obviously you need a conditional operator to check if a condition will return true or false. And you also need the syntax, the keyword, which are if, elif, and what? And else. Is that understood? So
Okay.
let's do something. So imagine I gave you a simple task to do, and let's assume in this task I have a list of students. So let's call them students, and that my students are going to be in a list. Let's assume we have a student called John, another called Ali, another one is Simbi, and another one is Shade. So these are the four students we have in the class. You understand? And you are being given a task to go ahead and check if the numbers of the students is more than 4. To check if the number of the students is more than, if the number of the students is more than 4, I want to say print the number of students is more than 4, else you tell me that the number is not more than 4. You understand?
Yeah.
Is that not a condition? That is a condition. So that means I needed to write an if statement to check if the number of these students are actually more than 4, right? And how do you, based on what we learned in the last class, this data type or this value here is what data type?
String.
Mr. Elijah, this is what data type? The student here is of what data type?
This
Are
is
you,
not string.
this is not a string. Is Mr. Elijah on the call? Alright. This is not a string. This is a list.
List.
This is a list.
This now this
Yeah.
Alright. So if
this is a
I
list.
if I want to check the length of a list, how do we do that? Because that is the only way I can know if the numbers of students in this class are more than 4. How do we check the length of a list? Or can we check the length of the list? Alright, you guys did not practice the last class seriously. Alright, so I can write a condition and say if len, and then you give what? You give your variable name students, because based on what we learned, we know that this len, we check the length of this object, and based on that the length of this object is basically going to be return us what? 4. But our condition is I want to check if the length of this student is actually greater than what? 4. This is a condition, and if it is greater than 4, you basically want to say probably there are more than 4 students in the class. And it's always good to always have an else. Else, what happens if I don't have more than 4 students? I'll just print error. When you execute this now, you can see that based on the condition, the students we have here, there are just 4 students in the class, and your condition is checking whether the length of the student is greater than 4. So that means it's only when this condition is true, that is when you get this executed. But when the condition is not true, it will rather execute this line of block that says what there are. So this curly brackets is just like a placeholder, you understand? So which use this curly bracket within the string to identify that something is going to appear here, you understand? So there are something is going to appear here, students in the class. Now what is going to appear here? That's why you see me calling this function dot format on the string. Then whatever value you pass within this bracket, whatever argument you pass within the function method format, it gets inserted into this position. As you know that the length of this student is 4, that is why you can see that we're having what? There are 4 students in the class. So this happened because of what? Conditional statement. Another example that we can look at. Any question on this? Any question?
No, sir.
All right. If you say no, I want to believe you understand. All right. So let's check if a given value is an even number. Yes or no. So let me give you a value. Let's assume I have a number which is equals to 5, and I ask you to write a program that check if this number is actually an even number or not. How will you go about it? Is by defining a conditional statement to check whether this number is an even number. And how do you know an even number in mathematics? Even numbers are numbers that when you divide them by 2, they don't remain what? Anything. Or basically they remain what? They remain 0. So we can check that in math in Python by taking the modulo of that number. So if I go ahead and say if num modulo 2, that means when you divide 2 by this number, or when you divide this number by 2, what is the remainder? So if the remainder is actually equals to 0, that means that this number is actually a what? Is actually
Even
an
number
even number.
S is an odd number.
So else it could definitely be a what? An odd number. If something is not an even number, definitely it's going to be what? It's going to be an even or odd number. So let me comment this guy out. So if you execute this, we get this is an odd number because 5 is really an odd number. If we try this with 8 or any even number, you will definitely get an even number because when you divide 8 by 2, the remainder is what? Is 0.
Okay.
Alright, so that is conditional statement for you. Alright, so we can look at more examples and more examples, but this is the idea about conditional statement. Any question?
So, so we said if num is divided by 2, what do we add is equals to 0?
Because you want to check if the result of this guy, what
The
will be equals to 0. That means when you divide, you know what modulo means, right?
yes, no.
Ahead.
Yeah.
So
That's
8
the
8
age.
8 modulo 2 will give you what?
I don't know.
8 modulo 2 will give you what?
From
That means when you divide 8 by 2, it will remain how many?
0.
It will remain 0. So it's like checking if it's 0 is equals to 0. So and we know that 0 is equals to 0, it's going to return true. And that is why you have this is even. But if you have, like, for example, if you have 7, 7 modulo 2 is what?
0.
7 modulo 2 will be what? You divide 7 by
The
you divide 7 by 2. is going to remain how many?
One.
It's going to
No,
be remain 1. Is 1 equals to 0?
no, no.
So that will remain, will return what? This is odd,
Oh,
because 1 is not equals to 0. But what?
Okay. The 8 that was there before. 8
Okay.
divided by 2 is equals to 4.
Remainder what?
zero now.
Remainder is 0.
Is 0, is 0 equals to 0?
Yes.
Then you have this is even.
So what I'm trying to say is, are we not supposed to put division sign there instead of that percentage sign?
If you put division sign there, we have learnt about Python. If you say 8 divided by 2, what will Python give to you, Mr. Elijah?
To give you four.
You
4.
said, is it 4? 8 divided by 2. You give you what? 4, right?
Yeah.
Okay, that's correct. Now, if this is giving you 4, is it giving you the remainder? It's not giving you the remainder. We are here looking for the remainder. Is Mr. Elijah even getting this now at all? We are here looking for the remainder, not for the value, not for the value that will get results when you divide it by 2. Because you said even numbers are what? Numbers that when you divide them by 2, they will remain 0. So we are looking for numbers that when we divide it by 2, is going to give us a remainder of 0. And that's why we are using what? Modulo instead of the normal division. Do, do you understand this at all? You don't understand.
But you,
That in Python, this
Mm.
particular task, it said what we are looking for is the remainder.
Is the remainder. We are looking for the remainder. We are not looking for the result when you divide it by 2.
yes.
We are looking for, okay, if I divide it by 2, what will it remain? That is what modulo do, to give you a remainder of a number after you've divided it by that divisor. All right.
Understood, sir.
Okay. Let's look at another task and then we move on from there. So imagine you are to just you have a certain student in your class and you want to like possibly grade them based on their score. So let's assume anyone who score between 100 to 80. Let's assume they have an A, and anyone between probably between 79 and 50, they are going to have a B, and anyone between 49 to probably 0. So this is just my own grade. They have a C. Now these are condition. Already we need to what? We need to first of all define the what? Input. And how do you define the input? Is by a variable. So that means I need to store this score in a variable. So let's assume a score. Can somebody give me a number between 0 and 100?
70.
70. Alright, so let's assume a student scores 70. Now you want to check if the grade of this student is going to be A, B or C. Now based on the grade we have on the screen, this person here is going to have what grade? Is he A or B or C? Is B, right? Now let's define that in our program using conditional statement. We definitely start with what? If. Now what will be the first condition? Because the first condition will be what? To check if what this man score is actually between 100 and 80. Because once it's between 100 and 80, that means you have what? You have an A. So that means if I want to define this, I will say what? Score is what? Less than or equals to what? 100. Is that not the word it be? That means the score must be what? Less than or equals to what? 100.
On
Right? Are you guys getting me at all? These are programmers. So you are DevOps engineer. These are not baby's class. You need to be responding.
Yes, sir.
You are checking if somebody's score is actually less than or
It's less
equals to
than
100.
100.
So that means from 0 downward, this person's score is going to fall there. But
All
at the
the
same time,
Yeah.
you don't want that score to be what? To be greater than 80. It should be less than
yes.
80 rather. It should not be less than 80. It must be between the range of 100 and 80. And that is where another condition can comes in, which is the what? And. So that means I'm checking if this score is less than or equals to 100, and at the same time the score must be what? Greater than or equals to what? 80. If you understand that mathematically, you will know that any score that form between 100 and 80 will mean that that number is less than or equals to 100 but greater than or equals to what? 80. That is the range between 80 and 90, 80 and 100. So if you meet this condition, you perhaps simply want to say print grade A. Now to form the other condition, what keyword will I use? Because there are still more conditions that you want to test. What keyword? I'll use the elif
Elif.
and check if the score this time around is less than or equals to 79, and at the same time that same score must be what? Greater than or equals to 50. And if you are within that range, I can say print the grade is B. If you like, you can still define the other condition too. In this case, I say once the score this time around is less than or equals to what? 49, and at the same time that same score must be what? Greater than or equals to what? 0. So I can say print this time around the grade will be equals to C. So if the score is between 100 and 80, that's an A. If the score is between 79 and 50, that's B. So if the score is not within this range, probably somebody score -5 or minus or 102 or 105 or 200, I can say invalid what? Invalid score, right? So that is what I want to do. So this is a condition. So if you do this now, if you look at this program and you read this program, first of all you see that I'm starting with an if and I ended with an else. That is a good practice. And every other conditions that follows the if, we have what? Elif. Now and you notice that I define this statement, this conditional statement, from the top to the bottom, because that is why I started from 100. I should have started from where? From 0 to 49. It's possible, but there's a challenge to that, because if you start your code, your conditional statement from 0 to 49, you know, when you are testing, you understand if the number is actually greater than 100, less than 100, it is possible that this condition will still be met. You understand? So whenever you are defining a conditional statement, rather, it's usually take what? Start with the top, from the top to the what? From the to the bottom.
Bottom.
So if I execute this command now, 70 should
Sir, I wanted to ask this grade you
yes.
put now. Is Python really case sensitive? Like it has to be.
Python is case sensitive. Python is case sensitive. But the grade I put here, these are just string. So anyway you define them is the way they will appear. But everything you see here that are code are case sensitive. You cannot call your score like this. It's not possible. Because what you define here is what? Small letter s. So you cannot come here and say capital letter S, because Python is case sensitive. Alright. So when you execute your code now, you see that we have a grade B, because 70 fall between 79 and 50, or 50 and 79. If you try any other number like minus 12, minus 12 is not between 80 and 100. Neither is it between 50 and 79. Neither is it between 0 and 49. So we should get what? An invalid score. Same thing if you try something greater than 100, like 102. We should also get what? An invalid score, because we believe nobody should score more than 100. So these are conditional statements. Alright. So I think I can close on that, right? Okay. So the next thing that we need to talk about after conditional statement is also talk about what? Loop.
Loop and repetition.
And that is the second control flow. Loop is the same thing as what? As repetition. Loop is the same thing as repetition. So let me comment this part of the code. So, and let's talk about what? And let's talk about loop. So when we talk about loop, we are talking about repetition. And when do we use loop? We have seen what we use conditional statement to do. We use conditional statement to check whether a condition is met. But when you are talking about loop, loop is used whenever you want to perform an execution more than one time. Whenever you want to perform a process or an action, and you feel this action is going to be taken more than one times, you can use what? A loop. An example of a popular game that we all know is Temple Run. If you look at Temple Run, the object is always running, right? This guy run, and I don't think I've seen anyone who has concluded that game, because the guy never gets to a finish. There's no finish point.
Definition.
So because there is a form of what? Loop there. So the game is meant to like run forever. But even at that, when the guy or when the object hits an obstacle, what happened? You have what? The game stop. You understand? Because it has hit an object. So that means in this case too, you can put your code to always run forever. When your code run forever, or when your loop run forever, we call that what? An infinity loop. An infinity loop, something that doesn't have an end. Infinity loop. This is not good for programming. Your code should not run for infinity. There must be a certain time when the loop is going to what? Is going to stop. So be very careful whenever you are writing a loop, not to run into an infinity loop, especially when you are using the while loop. So let's start with the while loop. Let's take a very
So how do you define loop?
loop means repetition. Making a process to run more than one time, basically. Loop, repetition, to repeat something, to repeat a code, or to make a code to run for more than one time. Imagine I ask you to print 1 to 10 or 1 to 5. If you want to print 1 to 5, look at something. I usually use that as an example for people. If I say print 1 to 5, based on what we've learned so far, this is the only way you can print 1 to 5, right? So but this is very difficult, especially when you have to print from 1 to like 100, or print from 1 to a million. How long will you do this? Now this is not scalable, right? So even though if you run the code, it's going to do what I ask it to do, to print 1 to 5, but we know you cannot do this every other time. Now if you look at the code, you will see that there's a form of repetition in that code. Print is getting repeated every time. So there's a form of redundancy in that your code. So there should be a way whereby I can just call only one print. If possible, I'll just call only one print. And that one print, I can wrap it into a form of code that will always call that print every time. In our life too, we have this kind of activities that whenever you want to perform a process, you don't have to like repeat it again. You can just call somebody to do it for you, or you call something or a program to do it for you. So whenever, for example, now instead of me having to type print, we are saying that there's a certain command or a certain code you can write such that he will call this print every time that you need it. And what is that code? That code is what? The understanding of loop.
Loop.
Let's try it with a while loop. When you are starting with a while loop, there's a keyword you use which is while a condition. So while takes a condition, and you have a, you have also what, the colon, and you know that the colon means what, indentation. So whatever code you want to run forever, or you want to run for some time, you put it what, inside that block. So imagine I put a condition and say while true, for example. You already know that condition will only return what, true or false. So let's assume my condition return true while true, and I say print 1. Pay attention here. While loop is something that might take, if you don't pay attention, you might not really understand what is going on here. So but I'm breaking it down. While true, whenever I want to define a while loop, you definitely will start with a what, a while keyword. Now condition will follow it. Now let's assume in this case our condition, your condition can be anything so far it gets evaluated to true or false. Now let's assume in this case my condition get evaluated to true. Now I'm saying print what, print 1. Are you with me? So, and we've said that while loop make a code to run several times. That means this print 1 will got printed how many time? How many time?
One.
1. What make you say 1? I only say print 1. I didn't say
Print
print
one.
1 this number of time.
Okay. That is to keep printing.
So this will keep printing. This will keep printing. I don't need to run this certain code. This will keep printing if you run it. Why? Because the moment your code, remember Python execute code line by line, the moment it gets to this line 52 and it check the condition and the condition is true, what will it do? It will print 1. Now one thing about while loop, unlike conditional statement, no conditional statement, once the condition has been met, it doesn't bother to check any other condition again. You remember? But in loop, especially while loop, when the condition is met, the program returns back to the condition again after printing the code or after executing the code within that block. It will go back again. It will not move further. It will go back again because it's a loop. It will go back and check the condition again and check, is the condition still true? In this case, yes, and it's going to print it again. Once it prints it, it will go back again, check the condition. The condition is still true. So which means that forever the condition remains true, and that means 1 will get printed forever.
Like forever.
Forever, yes. And that's why we call it what, an infinity loop. And if you mistakenly run this kind of code in production, that means at a point in time your whole resources, your whole computing resources will get eat up and your system might crash. So which is why you don't want to do this.
So
So
does it mean if we run it now, we can't stop it?
you can stop it. Yes, you can. If you run it, you definitely can stop it. You just run the code and then you stop it. Very simple. But I don't want to run it actually.
I'll, I'll close the English.
Eh? What do you say?
It's not what it's like.
Alright. So now in this case now we are trying to print 1 to 5. Now how do we make sure that our code prints 1 to 5 without running to an infinity loop? That means there will be something that there will be something you are going to introduce such that when this loop is printing, at a point when it prints up to 5, it's going to what? It's going to stop. So whenever I use a while loop usually involve a what? A count. A what? A count. So let me define a variable called count, and I'll say that count is going to what? Be equals to 1. I can use this count as my condition, and I say while count is less or equals to 5. Remember, this is a condition.
Yes, sir.
So this time around I'm not going to be printing 1. I'm rather going to be printing what? Count. Remember, my count is equals to what? 1. So that means my condition will check, my while loop will check, is 1 less than or equals to 5? True or false? True or
True.
false? True, because 1 is less than 5. So it's going to print what? 1. But still, if you execute this code, we've solved one problem, right? Because actually we have defined a condition, but still this condition that you have defined too is still an infinity loop, because every time this code goes back, count still remains what? 1. And every time 1 is still less than 5. So how do you make sure that this count does not remain 1? Is by incrementing it. So which means after my printing, I can increment that count. I can say count equals to what? Count
One
plus
plus plus.
plus 1. So this means that after printing the first count, increase the next that count with what? With 1.
One.
So that means after this line, count becomes 2. 2 is still less than 5. It's going to print 2. After printing 2, it's going to increment 2 by 1, making 3. 3 is less than 5. It's going to print 3. 3 plus 1, that's 4. 4 is still less than 5. It print 4. 4 plus 1, that's 5. This time around, 5 is not less than 5, but 5 is still equals to 5. What will it do?
Stop
It
there.
will print 5. 5 plus 1, this is 6. Now this time around, 6 is neither less than 5 nor equals to 5. So it stop.
It stops. Okay.
So that way, if I run my code, it's going to print what? 1 to 5.
Okay. That's how not to have infinity.
Infinity. So that means that when you are using a while loop, you must have a knowledge of how many times you want this iteration to take place. Take note of that. Whenever I want to use a while loop to make a process or a program to run for a number of time, that means we must have the knowledge of how many times the program is going to execute. Did I want this program to execute 10 times, 20 times, 50 times, 100 times, 1 million times? There must be what? You must know the boundary. You must know the number of iteration you want to do, so that you'll be able to increment each iteration after finishing the process. Is that
And do
understood?
we say that?
Yes.
Sir, do we say that when count is equals to 5, it will stop, it will not continue again?
If count is still equals to 5, it will still print based on our
Yeah, but
condition.
it will not continue. It will not continue to add one anymore.
It's no, it still add it. Always try and read code. You understand? After still printing 5, the program still say 5 plus 1, because it doesn't stop. After printing that 5, doesn't stop, because after it has printed 5, it say 5 plus 1. Count is now equals to what? 6. It was when now get back to this while loop and check 6 and see that 6 is not less than, neither is it equals to 5, and that is when it stop. You can see that at a point the condition were true. It is only when the condition stop becoming true, that is when the program now stop.
Okay. It's not like the program automatically stops because it saw it's not to be required.
No, 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 no. It stopped because the condition was not true anymore. The loop stopped because the condition was not true anymore. The same way the temporal example I gave, the temporal to continue running, but what happened when it hit an obstacle? It stop,
Stops.
because it has been programmed not to hit an obstacle, and once you hit an obstacle, you stop and start over again.
Okay.
Is that understood? So whenever you are using a while loop to perform a process, you have to be very careful. You understand? Of you have to be very careful not to run into what? Into an infinity loop. All right, let me give you a task to do here. This is the syntax for while loop. That's very simple. So let's look at it at the task, and I'll be using the,
So what of the normal loop?
which one is the normal loop? Do you
There's one loop now.
you mean for
There's no
loop?
while loop.
You mean for loop? Do you mean for loop?
I think there's
Do you mean for loop?
yes,
So if
yes.
to you for loop is a normal loop, what would be while loop? While loop is abnormal loop, abi.
Mm.
Mr. Elijah. They are
That's
both loop.
not same.
They are both loop. They are
No,
just two
because in
different
this
types
one
of loop.
we have
We will look at for loop too.
okay.
We look at for loop too. Both of them are loop.
Okay.
There are scenario where while loop is good. There are scenario where for loop is good. So both are loop. They perform the same process. Just that for loop to me too is also better than while loop because of the constraints. All right. Now, if you look at what I have here, the same student I have before. Now, I want you to do something for me. I want to write a program that will tell me the length of each student name. The length of each student name. What do I mean by that? That means when you run this code, for example, John. John is how many lengths? How many lengths? 4. The same way, Ali will return how many lengths? 3. So for each of the students' name, I want to write a loop that will loop through each of the students each of these students name and get me the what, and the uh, get me the length of each of the name. So that means I should be able to write a code that is going to loop through this length of the what, of the student. So I can basically say what, let's say while,
Print length.
are you printing length here? You have to define a condition. You understand? You have to define your condition first. You get? So you wanted to check, you wanted to write a loop that will run how many times? Maybe I should start from there. This loop I want to write now, how many times will it run? How many times will this loop run?
One time.
If the loop run one time, will you be able to access the how many name will you be able to access?
You should run 4 times.
It will run 4 times. So let's say count. It can be anything. It doesn't have to be count.
Since
So
I'm even change the screen everywhere.
so let's say count equals to 1, and I say while count is less than or equals to the length of students. The length of students. That means my counting will start from where? Let me start counting it from 0 so that you don't confuse you. If I start counting from 0, because John is on position 0, position 1, position 2, then position 3. Now I'm defining my loop to say while count is less than or equals to the length of students. And what is the length of students? It's 4. And are we supposed to get to 4 based on the index?
Oh,
The index is 3. The index is 3. So I can say minus 1. Alright. So which means I'm counting from 0 to what, to 3. Now that way I'll be able to have access to each of
I'm
these.
confused.
And because you guys are not paying attention, you guys are not paying attention, and I don't know why. I don't know why.
my, my own network is even cutting and coming up, cutting and coming up.
You are writing a loop. You are writing a loop. Okay, please, you guys need to pay attention. You guys need to pay attention. We have a long way to go. Now you have a student that has all these list of names. 4 students inside this class.
Okay.
Now individually, if you want to access each student, that's why I gave this example here. That means for us to be able to know the length of each student, we must be able to access each student one by one. And within a list, how can we access each of these students one after the other based on our last class? If I want to access John separately, Ali separately, Simbi separately, Shade separately, how can I do that?
So look for the length of each of them.
It's not the length.
Uh,
You get the index of each one of them.
Uh-huh.
So the index of John is 0, the index of Ali is 1, index of
One,
Simbi is
yes.
2, and this is 3.
Two.
Now that means that if I can get the index of each and every one of them like this, index 0, index 1, index 2, index 3,
One,
we
two,
get what we are looking
three.
for. But we don't want to do this
Yes.
manually. We want to do it in such a way that we can loop through them and write a code that will only get run executed every time. So that is why it's okay. Now let's write a loop to perform the action that will start counting from 0 and define a while loop that will be checking if our count is actually less than or equal to the length of the student. Now, if you say the length of the student is what? Is 4.
Four.
But our index should not stop at 4. It's stopping at
Mm.
what?
At three.
At 3. And that is why we say 4 minus 1. Because that will give us 3. Whatever the length is minus 1,
Minus one.
that is 3.
Mm.
So that means
Because I don't want to stop.
because I don't want it to
What
get
made
to
me thought
4.
this was that minus one. I didn't know how we
Because I
arrived
didn't
at
want it to
that.
get to 4. This should stop at 3. So that means I have, okay, maybe I should even call this count index. Index. Because we are trying to get the index of the student. So now that I know that, I can easily just say print student and then bracket the index.
Index.
So you can see that this time around I don't have to say student index 0, student index 1, student index 2, index 3. This is not dynamic. You understand? So but don't forget, I still need my what? Increment. Because this index will always remain 0. In order for it to move from 0 to 1, I will do what? Index equals to what? Index plus 1. And if I come here and execute my code, okay, let's take this guy out and let's run this again. Now if you run this now, you can see that it's getting each value in that particular list out one after the other. Why? Because of the index. So even though we have another student again, let's say Bayo, my code will still run fine, and I don't have to like come and say okay, this is the what, this is another person again, because I'm not manually putting the index there. Alright, that is loop. So we can get the index from that list by writing a loop to loop through over them and get the item out one by one. But the interest is that I now still want to get the length of those students, and this is simple. Let me see if my formatted string works here now. So I can say whatever the student is. So, and I just want to print out the what? The length of what? Of that student. If you look into this very well, it's very simple. So this time I want to get the length of that student index. So this one is printing the what? The student itself. This one is getting the length of the student itself. And if we execute that, why is this giving me, is there something with Python, uh have they upgraded this or something? I don't know why this is strange. This is really strange. This is indeed strange, honestly. Formatted string, can't see anything wrong in this code, and it keeps saying it's wrong. Alright, I'll check that up after the meeting. Alright, so let me just put this back. So you get the whole idea of what I'm trying to say here. Am I making sense here?
Yes, sir.
Alright, so let me just see another way I can print it out. So this print out the students. Okay, let me just say comma, then the length of the student, then their ID. So in front of them we should be seeing the number in front. So let me clear the terminal. What am I doing wrong here? Student and their index, comma, length, student and their index. Currently see what's going on with Python Studio. Seriously. Or maybe it's me. Alright, this worked fine. Okay, let me just print it after it. So let's say the length of each and every one of them. Alright, so that we can at least just see the length. Alright, so you can see John is 4, Ali is 3, Simbi is 5, Shade is 5, Bayo is 5, is 4. So this is a code I'll probably have written manually, one after the other. You understand? But with a loop, I can loop through the list and still perform that operation once without having to repeat myself. That is how a loop works. But with a while loop, you have to be very careful of what? Of an infinity loop. You have to define a kind of count and a kind of what? An increment to be able to avoid that infinity loop. Is that clear? All right. Let's talk about for loop 2. Let's talk about for loop. For loop is not as difficult or as stressful as while loop. So I will do the same task with for loop. So imagine you have this student and you also want to print out the same information. So now for a while loop, you also need to understand the syntax. It also starts with what? For, and this guy takes a kind of a loop variable, which I'm going to explain. For index in range, so let's say a range of what? Based on what we are trying to do, our range should be between what and what? What should our range look like? Between what and what?
Between 0
Between 0 and what?
and 3.
0 and 3. Alright, so I'll put that and you would see that but without even going far, we know that in Python, whenever you are using a range, the range will the stop point is not inclusive. That means this 3 it will not get to 3, because this stop point is not inclusive in Python. It will not get to 3, so it will stop at what? At 2. So to make it to get to 3, you have to say what? 4. Alright, so I can then have the same set of code I have here to print the student and also to print the length of the student. Now you can see how simple this one is. I don't have to say I define any count, and I don't have to define any kind of what? Increment, because for a for loop by itself, once it have iterates over the object, it will stop automatically by itself. So and that is why it's more better to use a for loop, because you don't have to be scared for using a what? For infinity loop. I hope that is understood. All right, so those are the two kind of loop that we have. Is Mr. Obi still on the call? Mr. Elijah, are you still on the call?
I'm on.
All right, so
I'm on the call.
all
At
right,
the time, I will not see your screen again.
okay, that should be the network. All right, so those are the control flow that we talk about: for loop and while loop. All right, but before we move on to the next one, let's take two or more questions on both of them. So let me create a file. Let me just call it example, and please pay attention this time around. If you pay attention this time around, you will definitely get it. They are not difficult. So let me just create some problem for us to relate to it. All right, so let's assume I have a set of data, and let's say we have uh, this data called cat, a variable called cat, and this cat has information like name, and we have let me see, let's say O1. Please pay attention. So we have name, let's say sugar, let's say the price, let's say is 45.20, and let's say the quantity, let's say this is 2, and let's assume I have another one. So let's assume I have another one. Let's call this one O2, and I'm just going to copy what I have there, then make some changes. Now, and let's say the name of this product is a what? Honey, and let's say this go for 145, and let's say the quantity is 3. Are we there, guys?
Yes.
So let's assume somebody add this kind of information to their cart, and if you look at this now, the structure of this data, can somebody tell me the data type? What is the data type of this variable?
Dictionary.
Is a dictionary. Why do you say it's a dictionary?
Because it has two or more variables.
What do you mean by two or more variables? Is that the definition of a
Um,
dictionary?
no. Um,
One, two things you will know that this is a dictionary. One, it has a curly bracket. That's how you know that this is a dictionary. Not only that, because even set has a curly bracket. Another thing you will know that this is a dictionary is that a dictionary will always contain key and value. So if you look at this,
yeah, that,
this is a
yeah.
key, colon, everything here is a what? A value. Now if you look at that value, even the value itself is also a what?
ASCII and value.
The value
ASCII
is also a
access.
dictionary. So that's what I wanted to know. So the cat itself is a dictionary because it has key and value. There are two keys here, a 01 and a 02. Or maybe I should call it product 1 and product 2. Or let's item. Item underscore 1 and item underscore 2. So this is one key and this is another key. But if you look at their values, the value is also a what? A dictionary. And the dictionary is made up of what? A key called name, value sugar, price, and quantity. Now this data you are seeing here, this structure of data you are seeing here is what we call JSON structure. What did I call it? A JSON format.
Yes. Mm.
This is a JSON format. This is the method, or this is the format in which data is being transferred between two computers. When a message or a data is being required over two computer or more than two computer, you need to connect, or you need to pass an information from computer A to computer B. We do that through what means an API, and those API carries data in a JSON structure, and those structure used to look like this. Now, but this is a dictionary we are dealing with right now. So now in this data, let's assume I ask you a question, and I asked you a question. The first question I asked you is this, and I said maybe print the names of all products added to the cart. I want to get the name of all the products. What are the name of all the products in this cart? What are the name? Onion and sugar.
Okay.
So before you can get those names, how do you print them out? How can you get the names out from that dictionary? Please be open. This is an open class. Say it. Nobody's going to say okay, what you said is wrong or not. I just want to be able to understand your thoughts. Now, this is a dictionary you have here. The dictionary is having basically two keys and two values. Now, for you to be able to get the name, and we've talked about indexing and slicing in the last class. How do you index a data from somewhere, either in a list or a tuple or a dictionary? Now, we need to index the value to be able to print out the data, because that is what the client is interested in. They want to see the name of those two products. We need this dictionary. So how will you go about it? Are we there? Uh,
Yes, sir.
all right. So if I want to print out the values, it's very simple, because we identify in the last class that in a dictionary, whenever you want to get the value, this is like your English dictionary. You have the word photosynthesis in a dictionary. If you want to look for the word photosynthesis in a dictionary, you want to look for the meaning, what will you be looking for in the dictionary? You will be looking for the key. You'll be looking for the what? The word photosynthesis. When you get the word photosynthesis, you can then look for the what? For the full meaning. The same thing in a dictionary in Python. If I want to get the value of something, I'm going to call the what? I'm going to call the key. So imagine I call the key item 1. Let me print this out. Print cat item 1. And I clear the terminal, and let's run this. Python example.py. Now if I execute this, what is it printing? What is it returning out? What is it returning out?
The name and the value, everything there.
Is it returning all the value for the item 1? We are not interested in returning all the value of item 1. We are only interested in what? Just the name. But at least we have gotten the whole value out. Now if I want to get the name, well, how will I get the name? At least I've assisted you to this point. Now I want to get the name. This is also a dictionary. The result, the output is also a dictionary. If I want to now get the name within this dictionary, that means I also have to call the what? I will call the what?
You call the name, sir.
So I call the name. So I can say name. And if I execute this, rather than it printing all the values of item 1, it's going to print the what?
Just the name.
Just the name alone, sugar. The same thing goes for item 2. If I say this as well, this prints what? Honey and sugar. But this is not proper, because what if this data, this cat, is like 1000 or 200? That means you now be calling it out one by one, one by one, one by one, one by one. This is repetition. You basically can just define a loop that will loop through this dictionary and help you to perform this same program. And that is where a loop comes in. Now, if I need to loop through this dictionary now, how many times will I loop through this dictionary to be able to get the name out? How many times?
2 times.
2 times. You understand? So even though it's not compulsory that every time you want to loop through something, you have to know their size. No. Because even in a real life program, you might not really know the size of your cat. It might increase later on. So you don't have to like say, okay, I must know the size first. No. I'm just saying this so that we can relate with what we're having on the screen. Now I need to loop through this dictionary. Now, should we use a while loop or a for loop? Because both of them you can achieve the same thing. Just that when you are using a while loop, you know that you'll be needing a what? An increment and a count. For for loop, we don't need that.
So let's use for loop.
So if I'm using a for loop, I can basically for, let's say for item, that means for item. So this is a loop variable. The item is a loop variable. It can be anything. In what? In cat. So let me just do this, and I'll say print item, and let's see what it's going to print out. Now if you run this code, now you can see that it's just printing the what, only the key, right? It's only printing the what, only the key. If I want it to print the value instead, right, I can say cat dot values. We mentioned all of this in the last class as the method. So if I want it to print the values for item, or let me say for value, let's say for value, it can be any name, for value in what, cat dot values. So that means for every value inside the cat dot values. And what are the cat values? These are the values, this guy and this guy. Now let's run this again. Now if I run this again, now this time I can see the values out as a dictionary. But I'm not interested in all the values. I'm only interested in the what? In the name of the values. So rather than now printing the value, now I'm only getting the name of the value. And if I run this instead, I get what? Honey and sugar. This is more better, because even though somebody comes to this program tomorrow and probably increase their carts, and they have cart 3, and they have maybe a shoe, and they have maybe this, I don't have to come to my code and change anything. Their cart has increased, my code is still the same thing. If I run my code this time around, you can see their input did not affect the way my code is still running. But if you have tried this way, that means you have to come again manually to come to your code again, type print and give the index and the key. That is not scalable. That is the importance of what? Of loop. Let's look at another problem. Imagine I needed you to help me to print the total amount of each item added to cart. The total amount of each item added to the cart. What does that mean? That means that you get the what? The total amount.
To add the attach together.
Eh? Come again.
Like, I mean, the total amount. That means you add the price together of everything.
You can't get the total amount if you don't multiply the price and the quantity. So item 1 we have its own total amount, which is the price multiplied by quantity, price multiplied by quantity, price multiplied by quantity. You understand? So we want to know the individual total amounts first. So how do I do that? That means I still also need to loop through the words. I will need to loop through the what? The dictionary. But this time around, what are the key that I need?
The price and quantity.
The price and quantity, the same thing. Okay, I was okay. Since I'm looping, let's say for value in cart dot values, since I'm looping through all the values in the cart, and I'm interested in what? In knowing the total amount, I can say the value called the what? The price multiplied by the what? Value
The value in quantity.
and the what? And the quantity. This now give me the what? Total amount. So I can say print
Total amount.
total amount. Now if I try this code now, let me comment this guy out and let's try this one alone. Now if I run this now we can see what we have. The total amount for each of them. Can we also add this total amount to the dictionary? Can we add it? Can we? We talked about that in the last class. You can update a dictionary. You guys did not revise, and this is very not nice. You guys did not revise anything. Alright. So you can update a dictionary. So if I want to update dictionary, I can say my cat dot update,
Okay.
and then you give a dictionary. You give the
The
key.
key and the value,
So let's say total amount. That's the key, and the value will also
and
be
the
what?
value,
Total amount.
total amount.
So after it's done, so I'm not print. I will now print my cat after the whole for loop. So because I don't want it to be printed dictionary every loop. No. Once you are done updating everything in the dictionary, I will now what? I will now print it outside the loop. So that means after the loop has finished executing. Now if you look at this now, you can see all of them has what? Total amount. The first one has a total amount. Oh, is adding it to maybe I should have said okay, let me if you look at what is happening here, you can see is adding it outside, not within. I want you to add it within this guy. You understand? So
Mm-hmm.
item 1 you should add it within this guy. So I can update by saying carts. Okay, we need to get the ID. mm. um that is possible though. But I don't want I just want to I don't want to make everything complex for you right now. Let me say very fast so I can do this. So this gives us the counts. I can say mm, okay. All right, let's do this. You will get this. So this is also possible in Python. The way you get the key, you can also get the what? The value. Because right now, for me to be able to do this, I need the key and the value. So instead of now calling dot values, remember we talked about another method called what? Items, that give you both the key and the value. If we remember, so this give you the key and this give you the value. So I can use this guy to get my total amount. But this time around that I want to update my cart, I can say cart key. So that get the key, and I say dot what? Updates, and I can update this guy with what? Total amount. That's the key, and the value will be what? Total amount. So this should work the way we want it. So if I run this again, let's see. Now you can see item 2 as is what? This whole data. You have what? The total amount is this, the price is this, the name and the quantity. If you look at item 3 too, also has the same structure. Total amount, price, name and quantity. If you look at item 1 too, has the same thing. Total amount, price, name and quantity. So we can see all those methods we discussed in the last class. We didn't just discuss them. That's because those are the foundation we needed to lay down. And thankfully we mentioned all these methods when we are doing in the last class. We mentioned all these methods of how you can get the keys from a dictionary, the values from a dictionary, the items from a dictionary. So you can see how this play. This can be a very simple code, but this is something very very complex if you don't know how to go around it. So Python gives us the ability to be able to collect the key and the value, and we can be able to what? To manipulate the values and also manipulate the what? Get the key and update whatever I want to update from there. I will leave this for you to go ahead and try out. So this is the functionality. This is how for loop works, or while loop works. They are both loops.
Mm-hmm.
So you can use them to what? To you can use them anytime you need to perform an operation and you need to loop over something to perform same task over and over again. All right. I hope that is clear. Is that clear?
Yes, sir.
All right. So the next one we move into now is what? Is function. We move down to function. So I'll create another one. Let's call it 11. Create a new file. Let's call it function.py. Now, what are functions? Can anybody tell me what function is? Functions. Anyone? Anyone, please? Hello. You guys are not encouraging me at all. Seriously. What are functions?
Don't you enter the one we had now?
Which of we've not even started? We've not started anything. No. What have you started? That's why I'm trying to even make this whole thing such a way that after we try something very ethic, we try to bring something that is not really ethic, so that we use as a form of relaxation. We've not even gotten into the main tools. All right. So when we talk about functions in programming, what should come to your mind when you hear about function is what is reusability. Reusability or dry code. So whenever
Dry code.
dry dry means what?
Okay.
Do not repeat yourself. So now what does that mean? In our last class and today's class, we've written some code. Like some of the code we've written is to check whether a number is an even number. Now imagine tomorrow you want to also check if another number is actually an even number or odd number. That means you have to write the same code again. Am I correct? So instead of having to repeat the same code over and over and over and over, you basically can create that code as a what? As a function. So when it is a function, you can reuse it. And that is what happens when we use a function called what? Print. I know I told you this is a function. Learn,
Yes.
I told you this is a function. Dir, I told you this is a function. Type, I told you this is a function. And they both do the same, they all do the same, they all perform different functions or different activity. Print is to print, learn is to check the length of an object, dir is to check the directory, or basically you can use it to check method you can perform with a data type. Type, that one can check the type of any object, and so many other. I told you these are what? Functions, right? Now we want to go into them proper and start defining our own functions. But before that, it will be good for us to tell us that we have different types of functions. We have what we call inbuilt inbuilt functions, and the inbuilt functions are the ones that are already inbuilt inside Python, like the one we defined below. And we also have what? Custom functions. And custom functions are the one you are going to be building on your own. Is that understood? So let's see how to build our own functions, and I'll be starting with checking if a number is an even number or odd number. With so how do you define the function in Python? To define the function in Python, you basically have to start with a keyword called what? Def, which means define. Then your function will have a name. Let's call it what? Let's call it what can we call it? A function that check if a number is an even number or odd number. What should we call it? Let's call it checker. So, and then you have an indentation as well. So any code you put within this function, like for example, I want to check if num, whatever number I have, if that number, and I check the modulo by 2 and is equals to what? Is 0. Whatever number that number is, I want to say what? Print it even. Else, I want to say print odd. It odd. Now this is a function, but you will notice something here. It's telling me that this num is not defined. So that's because I've not defined the num. So let me define the num within this function. Now what does this function do? What this function do now is that it's going to help you to check any number you're passing into this function. It's going to help you to check if that number is actually an even number or odd number. So if you run this code, if you execute this code right now, python 11 dash function dot py, if you execute this, Nothing gets executed, nothing gets printed out. Why? Because it's a function, and the function is just what? It's just basically a code you wrap somewhere, and it only gets executed only when you call it. So what you have done so far is to define a function, not execute or not call the function. You've only defined function, you've not invoke or call the function. Just like the way we have print. Print is a custom function, is an inbuilt function rather in Python. But before you can print anything out, you have to still call print. The same way you have defined this function, and before you can use it, you have to also what? Call it like this. You can see. It's just like the way you call your print too. But that one is what? Is inbuilt. It's the same way you also call this checker that you have defined. Am I making sense?
Yes, sir.
Alright. Now I've invoked the function. Since we said we need to invoke means calling the function. Now we've called it. Let's see what happens next. Let's run it again. Now when I run it, what do you see? What's the error? It's saying that this function
Type error.
requires exactly one argument. Why? Because when I was defining the function, I already specified that this function will only work based on a what? On a parameter. So I've defined a parameter necessary for this function to work. So if you are calling it too, you must provide the what? The argument. So which means if I pass 45 here, 45 now will come here and stand in place of this number. So it will now be like checking if number 45 is modulo 2 is equals to 0. And if you execute this now, we have what? It's odd. You can see how this work.
Yes, sir.
If I want
Why
to,
can't we just write the 45 at where the number is?
if you write the 45 here, if you write it 45 here, like this. Now, first of all, you can see that there's even an error here. It doesn't work. But let's even assume it now work. If you put your 45 here, 45 here, I will ask you a simple question now. Let's assume you've saved 45 here, 45 here. Very simple for you, and it worked. Now, what if you now want to use this same function to check for another number? Will you now change the 45 to that number again?
We'll not be repeating
You now be repeating the number. You now be replacing the number every time. Is that reusability? Is that reusability?
No, sir.
That's not reusability. We want a code that we can define once, and you can only use it anytime. That is what makes the life of every developer today very smooth. It's because you have some people that have created a code somewhere that you can always reuse any point in time. So which means if I want to check for any number tomorrow, I just have to call the function checker, pass the number I want. You can see, I don't have to repeat the code. I just need to write the code once, and I've written the code once. Anytime I just need it, I just call it. And if I,
Another question.
yes,
Another question. The invoking. You know when we're calling the checker, the
yes,
function of the checker, we'll put none inside inside the function.
when you were
But
defining it,
here, yes, and when we're defining it. So, but when we're invoking it, we put a number here.
yes.
Like I'm confused. The reason why I'm confused is we did not we did not put the number to add a variable to the number. That's why I'm just confused.
All right, there's nothing to be confused here, and this is why there's nothing to be confused is because the moment you've defined a function. Now, if you look at the moment I put my cursor on that checker, you can see that you said look at the doc type at the top. It's telling you that checker num can this any means it can take any value because Python is not strict. So it simply means that whenever you are now calling this function now, when I put my cursor on this one, on this checker, what do you still see? Num. So it means whatever you put inside here are standing in place of the what? Of the num by default. Are you getting this?
Yes, sir.
But if you want to be explicit about it, it's also allowed. You can say num equals to 45. This is also allowed.
Okay.
This is also allowed. If you want to say, okay, you want the code to be what? To be defined. People to understand what is going on. This is also still what? It's also still allowed. You understand? But mind you, if you don't put it there, Python understand. You understand?
Yes, sir.
Exactly. So this is what we call function reusability. So it simply means that tomorrow, if I'm working on that project and I have to also write a logic that check if a number is an even number or odd number, I don't have to write it again. I can just import the function or call the function within my program or even outside my program. So that's what we call reusability. Writing a dry code that is dry, that you don't have. So whenever you write, have a logic in your program that you know that this logic, I always need it every point in time. So you rather create it as a what? As a function, so that you'll be able to like reuse it any point in time. Exactly.
Yes, sir.
Yes, sir.
Any question? I'm trying to check my battery life. Any question, please?
No.
All right. Let me try one more example. So let's take one more example. Let's say a program, a function we can create. Mm, all right. Let's work on this example here. So let's come back to this example. Imagine I ask you to define a function that okay, let me bring it out from here, and maybe this is where we're going to round up with this. So imagine I have this data here. So these are our data, and we need to define a function that is going to help us to check the amount of each of the items, something like that we did the same something we did before. So I want to check the total amount, to calculate the total amount of each of the value in this particular cart. So there are several ways you can write your logic to achieve the same thing. But imagine I defined my function and I call it, let's call it calculate amounts. So, and this is going to probably, let me say, anytime I need this, I'll probably have to give what, two arguments. Because if you want to know the amount, just like we did earlier, if you want to know the amount of this value, how many things do you need? How many
Two
things?
things.
Two things. And what is that?
We need the value of the price and the quantity.
The price and the quantity. So I'll be needing the price and the quantity. So that's to calculate the total amount. And once I get them, basically what I just want to do, I'll just say, so I'm introducing the return keyword. So I can just say return, instead of saying to print price multiplied by quantity, I can just say print or return price multiplied by quantity. So this is also good. Now this is a function. So it simply means that if I come to my code where you were calculating this guy, so where you were calculating this guy, let's copy this again and put it here. Let me remove this guy. We've understood this. Now the same way we iterated over the dictionary, but instead of having this code here, we can basically say, okay, let's take this out, since we have a function that is helping us to calculate the total amount. But what do you need to put? You need to put the price to be equals to the what? The value of the what? Of the price, and the quantity, that will be equals to what? Value of the what? Of the quantity. So because now we have a function that is helping us to do the calculation. So when you find the product of the price and the quantity, now you can see that here my code is more like encapsulated. Nobody understand how I'm actually calculating the total amount. Nobody understood if I'm multiplying them or I'm dividing them. Or can you get that from here? You don't.
No, sir.
You don't. But yeah, it's defined. You can say how I'm doing my calculation. So my code can be hidden. It can be encapsulated. You understand? Such that you might not really know how this is being calculated. And that's why sometimes whenever you import a function, you might really not know how the function is performing the task. But you know that okay, you needed this argument to provide. So and these are the argument. So when I provide these two arguments, the guy understood that is what is to calculate the product of these two and then return the results into this guy and then update the what? The cat. You understand? Let me do something here. Let's say here we're actually rounding this up. So let's assume we round it up. So there's a function round. So whatever the result is, let's round it up to 2 decimal places. So compared to what we have before. So if I run this guy now, let's execute this. Am I not printing? Okay, I'm not printing the cat out. So let's say print the cat dictionary. Now, if I execute this now you can see. You can see. For item 2, you can see the total amount. For item 3, you can see the total amount. For item 1, you can also see the total amount. So this is what we call function. It's just to enable you to what? Reusability. And when you are talking about function, you'll be talking about what? The parameters, either one or more parameters. Like here there's one parameter, here there's two parameters needed. The value you ended up giving into the function is called the argument. So we look more into this. We are still by the time we are solving more problems, we are moving on and introducing yourself to Python. You will definitely come across this often, every time. Like for example, when you import a module, like we did in the last class, when you import the math module, and we say okay, we can call a function inside the math module called square root. Now when you are calling square root, what are you calling? You are calling a function. Now if you look into that function tell you that what? Look at it. How is that function defined? With def,
Mm.
then the name of the function, then followed by what? An argument. The argument is the x, or the parameter is the x. You understand? So that means whenever you call this function, you just need to pass just one argument. How he's doing the calculation, you don't know.